Hello everyone, we are moving on to our next topic, which is piecewise functions. So this is not really anything new on top of what we've done, it's just presenting it in a slightly different way. So over the last few weeks we've been talking about linear equations and we've been graphing them. And now we're talking about what if we, instead of having one equation that we apply to our whole xy plane, what if we instead cut it up so that for different parts of the graph there are different linear equations that apply. And that's how it gets the name piecewise, because we're cutting our equation into pieces. Before we can talk about how that works and what it looks like, we need to start with just a little bit of notation. So some of this you guys will know already, some of it you might need a reminder for, some of it might be new. Let's just remind ourselves. So here I've got my number line, let's just call it my x line, and we're just going to introduce a few symbols. Most of them you'll be familiar with already, if not all of them. The first symbol that we'll introduce is this one. Okay, so there's two parts to this symbol. There's the arrow looking thing and the line. This arrow looking thing means greater than, and the line underneath means equal to. So here we're talking about if something is greater than or equal to. So for example, I could say x is greater than or equal to 1. What would that look like if I represented it as a line on my number line down here? So I would say x could be 1 or anything greater than that. So I would draw a line off in that direction. This line here means x is greater than or equal to 1. Now I'm also going to, we also need to talk about what if I didn't have that line underneath. So what if I just had x is greater than 1? So it can be anything greater than 1, it just can't be exactly 1. How would I represent that on my number line down here? What I'm going to do is, I'm going to, instead of drawing that dot there, which is totally coloured in, I'm going to draw an open circle. And then my arrow off in the direction. So this sentence means x is greater than but not equal to 1, and I represent that with an open circle and my line going off in the right direction. Okay, we could also of course flip those symbols around. So let's say for example I had this. This is the opposite, so it now means x is less than or equal to 0. So I'm going to represent that with something that will look the same, pretty similar to this one, but now it's x could be 0 or anything less than that, so off in that direction. And of course, I could also then have x is just less than 0, but not equal to it. And the way that I would represent that is the same as before, with an open circle and my arrow going off. So this means x could be less than 0, but the open circle means it couldn't be exactly equal to 0. These are the 4 symbols that you need to be familiar with for this topic. And you also need to be familiar with the idea that if it's greater than or less than and equal to, we represent that with a filled-in circle. And if it's greater than or less than but not equal to, we represent that with an open circle. We could of course have any variation, any combination of these symbols that we want. So the last example we'll put on here is, let's say I had something that looked like this. So this sentence means that x is greater than or equal to -2 and x is less than 3. So greater than or equal to -2, I'll represent that with a coloured in circle at -2, and x is going to be anything off to the right of that. And x is less than 3, I'll represent that with an open circle at 3, so x could be anything in between those two, and that's what it would look like on my number line. Okay, using that, let's move on to talk about piecewise functions. Okay, let's start with an example. Let's say I had the equation. Y equals x plus 1. We all know what that would look like. It would have a y-intercept of 1, and it would have a gradient of positive 1, so it would go off in that direction. But let's say I limited that equation, and I said that it is for x is greater than or equal to 0, y equals x plus 1. I've just limited where that equation can actually be drawn. Let's add another equation, and then we'll see what it all looks like together. It'll be easier if we have two equations to deal with. So what if I say for x is greater than or equal to 0, y is x plus 1, and for x is less than 0, y equals negative x plus 1. So I've got two different equations. One equation applies when x is greater than or equal to 0, and one equation applies when x is less than 0. So how do I draw that on my axes? Well, this line here, which is the y-axis, that is my line of x equals 0. All along that line, x is 0. So I can split my graph into two sections. The section on the right of that line, which is the section of x is greater than 0, and the section on the left of that line, which is the section of x is less than 0. And each of these equations is going to apply in its respective area. So let's start with this first one. Y equals x plus 1. That'll have an intercept of 1, and then it'll go up with a gradient of 1, so it will look something like this. And notice I haven't drawn it at all on this space of the graph because it only applies when x is greater than or equal to 0. Let's look at this next equation, y equals negative x plus 1. So that's also going to have a y-intercept of 1, but now it has a gradient of negative x. That means it's going down, it's downward sloping, and it will look something like this. And notice that one now goes off in that direction because it applies for anything where x is less than 0, so it applies anything to the left of that x equals 0 line. This line here cannot continue over into that area, and this line here cannot continue over into that area. So that's what it would look like. Now I want to do one more example, because notice that here I've given you an example where the two equations, the two lines, meet up at the same point. But it doesn't have to be like that. So let's look at one more example. And let's say that I had these two equations. I had for x is greater than or equal to 2, y equals 2x minus 4, and for x is less than 2, y equals negative x. What would that look like? So first of all, I'm now not worried about the x equals 0 line, I'm worried about the x equals 2 line. So that is this line over here. When x equals 2, the x equals 2 line is anything when x equals 2. So that red dotted line there, anything to the right of that line is x is greater than 2, and anything to the left is x is less than 2. So let's look at this first equation. Y is 2x minus 4. That will have a y-intercept of negative 4 and a gradient of positive 2. So that means for every 2 that I go up, I go 1 across. So these are the points along my graph, but notice that only a couple of them lie in the correct area to the right of the x equals 2 line. So if I'm going to draw this, it'll look like that. Something like that. That's a bit wonky, but you get the idea. Straight line off in that direction, and I cannot continue it down in that direction because I would be down in that. I can't continue it down in that direction because it only applies when x is greater than 2. Next equation, y equals negative x. So the y-intercept there is 0, so it'll cut straight through my origin, and it has a gradient of negative 1. But this whole area over here, I'm drawing it as a dotted line because it's to the left, so it's so that's the area where it applies. If I continue drawing my dotted line all the way through, only the area to the left of that is x is less than 2, so only this bit becomes the line. Okay, notice that these two equations, these two lines, do not meet up at the point x equals 2, and that's okay. The way that we would represent that is if we jump back to how we did the notation here, let's remember the way that we could represent differently the equal to or not equal to by either filling in the circle or not filling in the circle. So when there is a discontinuation here, when there's a jump from one equation to the other and they don't meet up, then here x is greater than or equal to, so this graph will have a filled in circle there at that point. Whereas this second equation, y equals negative x, that's only for x is less than 2 but not equal to. So I would draw that with an open circle at the point where they jump. Okay, so just quickly to recap, piecewise functions are when I have linear equations that only occur in pieces. The important information to remember is make sure that you have a good grasp of this notation, as well as the difference between a filled-in circle and an open circle. And the way that I would draw these graphs here are two different examples. If they meet up, then it's a bit easier. I just draw each one in its respective area where it tells me to draw it, and if they don't meet up, then I still draw each one in the area that it tells me to, but I also have to look out for whether I'm going to draw it as an open circle or a closed circle, depending on if it is equal to or not.